Alright guys, welcome back. Got I would say definitely on the harder scale of problems right here, but I think once we get to this simplistic solution, as always, I think it'll clear up a lot and give you a nice foundation to work through with this one. So diving right in, Leetcode 207 course schedule. There are a total of num courses you have to take, labeled from 0 to num courses minus 1. You are given an array of prerequisites where your prerequisites at index I equals A of I, comma B of I, and that indicates that you must take course B of I first if you want to take course A of I. For example, the pair 0, 1 indicates that to take course 0, you have to first take course 1. Return true if you can finish all courses, otherwise return false. I would let the interviewer know I understand I'm getting a list of prerequisites where the initial number, or the A number, is the course I'm trying to take, and the B number is the course I've had to take prior to it. I want to go through and see if it's possible to take all the courses, and if it is, I'm going to return true. If it's not, I'm going to return false. So the first question that pops into my head is, what would keep me from taking all of these courses? Well, as you can see down here, in example 1, you got the simplistic 1, 0. So to take course 1, you have to take course 0. There's nothing you have to do to be able to take course 0. So it is possible. But down here you've got to take course 1, you have to take course 0. To take course 0, though, you have had to take course 1. So that stops you in your tracks right there. That is the reason that you cannot, that's something that would hold you back, is where there's a cycle where to be able to do course 1, I have to take course 0, but to do course 0, I have to take course 1. That's not possible. And again, you could have something like to take course 0, you've had to first take course 2, but to take course 2, you've had to take course 1. So course 2 could have a prerequisite of course 1. Basically, they've messed up somewhere and made it where it's impossible for you to do all these classes because a prerequisite overlaps, or a course that you can't get to overlaps here, kind of thing. So again, you're trying to detect a cycle. You're trying to see if this course has been a prerequisite before that you need and haven't finished yet. Is it still out there and now you can't get to it because you have this one outstanding? So what does that look like in a game plan here? What do we need to be doing? So the obvious thing is we're going to have some kind of set or list to keep track of what we visited and what we haven't. So what prerequisites we've done, what we have left going for that particular course. So like if you were going through 1, you'd have 0 as its prerequisite. So then you would look at 0 and see that you have 2 as its prerequisite. So now to take 1, you know you have to take 0 and you have to take 2. When we go to take 2, we have to take course 1. Well, course 1 is already going to be in our visited set because we visited it to start, and that's going to tell us this is not possible. This is in the visited set already. We can't take it. We're waiting on some other stuff, so we definitely can't take it to take that, and it's just going to ruin the whole thing. So we're going to have a visited set, and again, that can be a list or whatever, but we're going to call it a set just because a set can't contain duplicates, so it makes it kind of work more efficient, but it's not really even a thing. It's fine. So going past that, we're getting this simple list in here right here, like a 2D list or whatever. We could work with that, we could make things work, and we could kind of code around it, but the easiest thing that's going to be happening here, what we could definitely make things clearer, is to utilize an adjacency list, or in this case an adjacency map. So that'll allow us to take this 1, and if we had another little 1 right here where it was 1 and 3, we can map, hold on, we can have our adjacency list where when it popped out it would have 1, but it would also have, and it'd have the 0, but it'd also have the 3 there. So that's what we're wanting to do, is an adjacency list map to clear it up, make it easier to work with. So that's another thing we're going to want to have on here. When you're talking about an adjacency list, so this is again how problems build off of each other. An adjacency list is basically synonymous with utilizing a graph. So with a graph being in play here, DFS or BFS should immediately come into your mind. I like the DFS recursive solution that I've seen, so we're going to utilize that. I think it's very easy to wrap your head around. So what is that DFS recursive solution going to be doing? It's simply going to see, like we talked about, if the course we're visiting has already been visited. So it's going to compare it to that. If not, it's going to look at its neighbors or its prerequisites or whatever, and it's going to go through and do the same thing for them while adding to that visited list. And if we stumble on one that's been visited, it's going to return false and knock us out of the whole thing. If not, we'll keep returning true, keep returning true until we've done all the courses and gotten out of it. So what else will we need here? Again, we're going to need a for loop to go through all the courses, and we'll say in range num courses, and that's where we're going to be running the DFS. And all we want to do on that DFS, if we ever have one that returns false, we just want to return false for the problem. If one of these DFS, one of the DFS entrants or whatever you want to call it, doesn't work out, then none of this works out. If we can't take one class, then we can't. It's done for the whole thing. So what does that look like in code? So let's go here with our game plan. And again, guys, these are ones like this course scheduling mess. To really be able to do these problems and do them well, you need to get so much exposure to these problems and problems like it. And it wouldn't hurt to have a little cheat sheet and know, okay, for course schedule, an adjacency list comes into play. Just something that you remember in your mind instead of trying to memorize this code and memorize step by step. Just know, okay, I need an adjacency list and I need a visited set makes sense. You could probably get to that on your own. And that will fuel the rest of the problem and help you remember what you've got to do. But you want to probably pull out some key concepts and make your own little adjacency list of all these Leetcode problems, especially this 75 list, and put, okay, if I'm doing two sum corresponds with a hash map. That's the best way to do it. But anyway, getting off topic here, I've got course schedule where I'm getting a list of prerequisites passed through. All right, so just like we talked about here, that's what it's going to look like. So what I'm going to do is I'm going to go ahead and make a visited set, and that's just going to be an empty set right now. And the next thing I know I want to do, so just going with my game plan here, I want to utilize this adjacency map. So I'm going to say for course, so that's going to take the first number here, and the second number is going to be a prerequisite in prerequisites. And what it will happen, I'll say, and another thing that I want real quick, I want to have obviously my adjacency list before I start passing stuff into it. I'm going to call it pre-map, and it's going to be this, obviously a hash map, and we're going to say I, and it's going to correspond with an empty list now, and how many spots I need, I'm going to say for I in range, lowercase for I in range num courses. So that's going to give me this index or whatever, and this number. So I have 0, 1, 2, 3, 4, 5, whatever, the course itself, and I'll have an empty list with it. Then I'm going to say for course, so my course is going to be 0, 1, 2, 3, 4, 5, however many courses I've got, and the prerequisite is just going to be that second number coming in there or whatever. So say for course pre and prerequisites, so pulling all this information out again, and it'll do pre-map at cores, which we have all that set because we've already have our indexes here. So this course that's coming through, whether it's the 1, 0, 2, 1, whatever, it's going to link up to that, and it's going to append to it. So it's going to put the corresponding data with it. It's going to append the prerequisite. So that's how you get this 1 and the 0, 3 corresponding with it in the hash map. So we're going to do that for all of that. That's going to set up our adjacency list. Once we have that set up and we've got our visited set, it's time to go ahead and and this is where your game plan again comes into fruition because you're wondering what to do next. Well, you know you need your DFS function, so you're going to say def DFS, and the only thing you can really pass through it that makes sense is course. So you're going to come here, and again, what we want to check, we're trying to see if there's a cycle. If to take 2, I have to take 1, but to take 1, I had taken 0, and to take 0, I had taken 2. that's what's going to stomp me out of here. So I want to see if course is in visit set. And if that's the case, then I'm going to return false, and that's going to return false for this whole thing. The other little base case we have here is if pre-map course equals an empty list. If that's the case, there's nothing stopping me from taking this course. I don't have to worry about it. I can return true. It's just a non-issue. No big deal. I don't even have to add it to the visited set or anything like that. It's just ready to roll. So if those don't come to fruition, then I'll go visit set, because I know I'm about to go through its prerequisites, and I want to make sure that one of the prerequisites to this is not my course that I'm on right now, or that my course is not a prerequisite for something else that needs one of these prerequisites prior to the course, or whatever. So I'm going to say visit set.add course, and then I'll go for pre, and this is a lot like any other DFS, BFS problem. They're always very, very similar. You're looking at its neighbors now. So for pre and pre-map course, and what we'll do is we'll just run that DFS on them. We'll say if not DFS. So if when we go through these courses, if it returns false, so if we get through there and one of the courses is in the visited set, and it's basically stopping us from being able to take that course, if not DFS, we will return false. We'll break the loop. It'll be done. We don't have to wait for anything else. It's all over. It's done. All right. Once we get out of that, and again, we're going to be taking this prerequisite and going back through here, back through here, back through here for as many prerequisites as there are. I'm going to do it for the prerequisites of the prerequisites, etc., etc. We're going to get through every single one. If we make it out of there with nothing being a problem, we will go here and say visit set dot remove course, because it's not an issue anymore. We don't want to have it in there for the next one because there's not any prerequisites on there right now that could prohibit us from taking that course. So it's back to being fair game. So visit set dot remove course, and then we can go ahead to make things faster. We can say nothing's stopping us from being able to take this course, so we can go ahead and make it literally where nothing's stopping us and update its adjacency map where it has an empty list. So that way, if we come across this again, it'll just go right to here and return true and save us a lot of time. All right, and then we're going to, of course, return true, and that'll keep the true going. And then all we need to do, we have in our game plan, is that we just need to do this for every single course. So we need to come out here and say for course in range num courses, and just say this, if not DFS, so we're running DFS on the course, just like we did over here, if not DFS pre, if it returns false, we want to immediately just return false for the whole thing. If we get through all of these courses, and all of these courses get through their prerequisites, and there was never a course in the visit set, that course itself was never in the visit set already, so it didn't have to be a prerequisite of something else needing a prerequisite or whatever, then we can return true. We've made it through all of them. All right, so I'm going to bump all this down here on one page so we can look at it a little bit better. Hopefully this makes sense, guys. Again, you've got your prerequisites coming in as a list that it's not prohibiting us from doing the problem, but it's better to do an adjacency list. And that's something I would definitely write down as a key component of this problem. You want a visited set because the only thing that's going to keep you from being able to do all these is if there is a prerequisite that's impossible to do, because you need to do that prerequisite. To be able to do that prerequisite, you have to do something else that you can't do. The terminology is I'm getting a little mixed with what the words I'm saying, but either way, so to like take this one, you have to take 0, but to take 0, you have to take 2, but to take 2, you have to take 1. So that's what I'm getting at here. That 1 would be in the visited set already. It would make it where you couldn't do it. Once we get through all the prerequisites of 1 and see they're all fine, then you would take everything out of the prerequisites again and come here to this 1 and say, okay, course 1, I need course 3, there's nothing stopping me from taking 3, boom. Instead of going to this course 1 and saying, oh, course 1's already in there. No, this is a brand new thing. All this would be done. It would be removed, etc., etc. So you have your visit set. You're going to come down here. You're going to do your DFS. And you could have done BFS, etc., etc., but this is recursive DFS. I think looks really nice for this one. And you're just seeing if it's in the visited set. If it doesn't have any prerequisites, you can go ahead and jump to true. If these two conditions aren't met, you're going to add it to the visit set and just see if you come across it again while you're doing the prerequisites. If you come across it again while you're doing the prerequisites, if a prerequisite of the prerequisite is this initial course, you can't do it. And then, of course, we're going to do it just for every single course. So that was a mouthful, guys. Again, I really hope this simplified it for you, at least to an extent, and helped you kind of figure out what's going on. For complex problems like this, you're never going to memorize all this code, so definitely pull out some key components, this visit set, this adjacency and list, and knowing DFS, and just put it beside this problem on a cheat sheet. And then just keep getting exposure to these problems, keep getting exposure, keep getting exposure, keep getting exposure. The good news is a lot of these DFS, BFS problems work the same as long as you can identify that it is DFS, BFS. They work very similar where you're going to go through the neighbors and you're just going to keep running DFS recursively or BFS while you have stuff in the queue, etc., etc. So thanks for watching, guys. We'll be back with another one shortly.